So, hello everyone. I am Mohammadreza Tavakoli, one of the PhD students from the Gabor's team who work on this project. In this part, I'll talk about two important components of our system. The first one is our topic extractor component, in which we try to decompose skills into meaningful knowledge topics. For this research, we collaborate with the Tehran Polytechnic. As Gabor said, the general objective of eDoer is to empower learners through personalized learning and curriculum recommendations based on labor market information and open educational resources. In this part of my presentation, I'll talk about the curriculum recommendation part, and in the next part, I'll focus more on the personalization part and the quality related parts. To recommend a curriculum to our learners, in the first step, we needed to match jobs with their required skills, which Jarno will present later today. As the second step, we needed to decompose skills into meaningful components, which helps us offering a more suitable learning path. For example, if someone wants to learn machine learning skill, it's important for us to know which knowledge topics should be covered. So the objectives of this part of our project were: one, defining the knowledge topics that should be covered to achieve a skill, and two, extracting the topics that are covered by an educational content. To start exploring this part, we collected 67 machine learning lectures, 27 lectures on text mining, and 29 SQL language lectures from Coursera and Khan Academy. And afterwards, we used latent Dirichlet allocation, LDA, which is a well-known method for extracting topics from documents. So LDA gets the number of target topics as parameter K, goes through the input documents and provides K topics and the distribution of the words for each of the topics. For example, if we have different parts of a newspaper, which covers 3 areas of, for example, sport, politics, and healthcare, we need to set the parameter K to 3. And the output of the LDA method would be something like this. So topic 1, politics, Biden, Middle East. Topic 2, for example, football, Champions League. And topic 3, corona and vaccination, for example. And these numbers are the probability of each word in its topic. For example, in this case, 79% of the political documents, in the 79% of the political documents, Middle East is mentioned. However, we usually do not know the exact number of topics in the documents. So I mean parameter K, which we had for the newspaper example. For instance, in our case, in skill decomposition, we don't know the number of topics which are covered in machine learning or skill language. So we used a coherence measure for different numbers of topics after applying LDA. And with this, we checked that with which K parameter here between 2 and 10, the words that are extracted for each of the topics have the highest coherence with each other. Here you can see our results on machine learning. This plot shows the coherence measure for different numbers of K. And as you can see, 9 got the highest coherence rate. So we ran the LDA model with K words for topic 1, cluster, local, centroid, muse, and we consider this topic as clustering. And topic 2, approx PCA representation, dimensional as important words, which we considered as dimensionality reduction, and so on. Here is our result on text mining lectures. As you can see, we extracted 7 topics here, and here is our result regarding school language, which we selected 5 as the best K parameter. So afterwards, we used a YouTube dataset, including 550 educational videos on our target skills. I mean, machine learning, text mining, and SQL language, and asked 3 experts to label those videos using our extracted topics or other ones if they are unavailable in our list. And you can see on average with the F1 score of 79%, our topic models detected the topics correctly. Let's show this component in the platform. So you can see here how we use our mention component and list the knowledge topics that should be covered for each of the skills. I mean, we have used our topic models to decompose these skills into these knowledge topics. In this case, for example, for Python language, you need to pass these topics in order to achieve Python programming skill. And for example, for machine learning with Python, you need to pass these topics. Moreover, for our crowdsourcing platform, we developed something here. For instance, if someone wants to add content here, so let's search. Let's go to YouTube and search for random forest, for example. Let's go for the second one. So if I want to add this content, so we retrieve information from YouTube, and here is our suggestions regarding the topics that are covered by this content. And in this case, our model detected that it's about machine learning, and these are the target topics, which in this case looks good. So I can easily add these topics to this content and easily save this content into our system. Let's get back to our presentation. So to summarize, so we proposed an approach to define the topics that need to be covered in order to achieve a skill, with applying text mining techniques on existing related educational resources. Also, we showed how we can use our models to extract the topics of a specific online educational resource to facilitate the content adding process. Look, as the future steps, we plan to test our method on new areas such as healthcare related skills or soft skills such as communication and so on. And this is the paper that we published in European Commission on Technology and Enhanced Learning, ECTL 2020. Let's go to the next part. Afterwards, we can have a question feedback part for both components that I'm presenting. So here. So last week, I presented this part in LAC conference, and Gabor told me it's better to at least smile on the first slide. So although it is not the first slide of my presentation, as it is the first slide of this presentation, so I should smile. So the second component that I'll talk about is our metadata analyzer, in which we collaborated with the University of Bonn, and Mirat is here. Again, let's get back to our objective: empower learners through personalized learning and curriculum recommendations. based on labor market information and open educational resources. Now, in this presentation, I'll talk about an important step towards offering personalized recommendations. To offer such personalized educational recommendations, we found that open educational resources, OERs, have high potential as they are continuously created by people around the world with different contexts, different languages, levels of expertise, and so on. Although we found OERs incredibly useful, we understood that using OERs as a source for learning or even teaching is very limited in the current learning environments. So the question is, what limits the use of OERs? So let's check two important components of well-known online services. The first one is the search, which is usually used when users know approximately what they want. And the second one is the recommendation services, which help users find the most related items, even if they don't know what exactly they want. So if we cannot find our products, movies, or questions through searching in Amazon, Netflix, or Stack Overflow, would we use their services? How about not receiving their recommendations, for example, during our shopping based on our usage history or preferences? We have the same situation in educational services. If we don't find or receive learning materials, we wouldn't use the offered services. And based on our investigations, there is a lack of high quality OER-based search and recommendation services, which we believe limit the use of OERs. So now the question is why OER platforms and repositories still underperform when offering search and recommendation services. We believe that metadata plays a key role here. For example, if Netflix doesn't know the genre of the movies or their directors, actors, or actresses, can it provide high quality search and recommendation services? The same situation for Amazon. If they don't know the title, the price, or the category of their products, they simply cannot provide pleasant services. So the objective of this part of our project was analyzing the quality of OER metadata. To do this, we collected 8,887 OERs using the Skills Commons API. As a result of two search terms, information technology and healthcare. Skills Commons is a well-known OER repository, which is maintained by Mallet. And these are the fields we collected for each of the OERs: URL, title, description, subject list, level, length, accessibilities, and language list. Also in Skills Commons, you can find information regarding the manual quality control of OERs. So we collected a field called quality control, which shows if an OER has passed through manual quality control processes or not. Afterwards, we plotted the relationship between the quality control field and the availability of each metadata field. So in each plot, the left part, I mean here and here, shows the OERs which include the metadata field, and the right part shows the OERs which do not include that metadata field. Also, the blue ones are the quality controlled OERs, and the orange ones are the OERs without quality control. As you can see, level metadata and time required metadata are available more in the quality controlled OERs. So for example, around 5,000 of the OERs have level metadata, I mean here, these two columns, and more than 4,500 of them are quality controlled OERs. Also around 2,500 of the OERs do not have level metadata, these two bars, in which more than 3,400 of them are OERs without quality control. We have a similar situation in language and accessibility metadata. Quality controlled OERs, I mean the blue ones here and here, have more available metadata, and the OERs without quality control, the orange ones, this one and this one, have more unavailable metadata. So these plots showed us a clear increase in metadata quality in terms of availability in the quality controlled OERs, which can be a result of manual quality control. As a result of our exploratory analysis, we concluded that we can use the quality controlled OERs to benchmark OER metadata fields. So as the first step, we calculated the importance rate for each of the metadata fields based on their availability rate. For example, we set the importance rate of title to 1, as all of the quality controlled OERs had a title field. Or we set the importance rate of accessibility, here the last row, I mean, to 0.59, as 59% of the quality controlled OERs had metadata regarding accessibility. And after that, we normalized these importance rates. You can see in the third column. Also, we plotted the values of title, description, and subject length in terms of number of words. Here you can see for the title. And we found that they had a distribution similar to normal. Based on that, we built a rating function using the reverse of z-score in the normal distribution for these three fields. So the closer an OER title, description, and subject length to the mean of the distribution in the quality controlled OERs, the higher the rate is. And we also used a Boolean rating function for the remaining 4 fields. Afterwards, based on these ratings, we created 2 metadata-based scoring models. The first one was the availability score, which is calculated as the summation of the importance rate for the available fields. So the more important metadata field an OER has, the higher the availability score is. Also, we defined the normal score, which is calculated based on the normalized importance rates and the rating functions I showed you in the previous slide. So an OER with similar metadata values to the quality controlled OERs will obtain a high normal score. We are going to use these scoring models in our crowdsourcing platform, which help the contributors to provide high quality metadata. As you saw, there was a close relationship between OER metadata quality and OER manual quality control field, which we can use as a proxy for OER content quality. So we believe that the more high quality metadata an OER has, the higher the chance is that it has high quality content too. As we found manual quality control essential in our analysis, we plotted the rate of manual quality control in the recent years in our data set, and we found a clear decrease, as you can see in the plot, in the rates, which can be because of the growing number of OERs and subsequently the impossibility of manual quality control. So based on one, the close relationship between metadata quality and content quality of OERs, and 2, the need for automatizing the quality control processes for OERs, as the second result of our exploratory analysis, we decided to develop an intelligent metadata-based quality control method. To develop this intelligent model in our data set, we had 4,651 OERs with quality control class and 4,236 OERs in without quality control class. So we built a random forest classifier to predict if an OER has passed through quality control processes or not. We use 80% of our data set as a train set and the remaining 20% as the test set. And in the end, the model was able to classify the OERs to the target classes with an F1 score of 94.6%. And when we checked the importance rates regarding the features, we knew that our defined metadata scoring models, I mean availability score and the normal score, achieved the highest importance rate in our random forest model, which showed that they can be used not only in the metadata scoring but also in the quality prediction models. This prediction model is also used in eDoer to filter out low quality materials from the system. To evaluate our models in another context, we collected 884 educational videos from YouTube in 32 different topics from 2 areas of information technology and healthcare. Afterwards, we used our prediction model to classify the videos into with or without quality control classes. And in 27 out of 32 topics, means 84.3%, the group that were labeled as with quality class had higher ratings in YouTube, which shows that our model can be generalized for other repositories and other resource formats. To summarize, we talked about the importance of metadata in offering high quality personalized services. And also we showed that there is a close relationship between the OER metadata quality and OER manual quality control processes. And based on this result, we benchmarked the metadata fields using the quality controlled OERs and built a metadata-based quality prediction model, which facilitates the OER quality control processes. During the next step, we plan to text mine title and description fields and extract some best practices for these 2 fields in open educational resources. Also, we definitely need to improve our models by adding more metadata fields like author and validate them on bigger data sets. And these are the papers that we have published by now on this topic, one in ECITL 2020, one in ICAL 2020, and one in LAC Learning Analytics and Knowledge 2021. Thanks for your attention. And this is a type of Iranian ice cream from Shiraz city that is very, very delicious. Again, thanks. And if there is any question or comment, I'd be happy to hear.
Thanks, Reza. Let's have 2 questions. We have time for about 2 questions. Anyone? Margaret.
Thanks a lot for the interesting question. Maybe I overheard this or something. What exactly is meant by accessibility? Because for me, I mean, OER is by nature accessible, otherwise it's not OER. So what's the definition?
So let me share my screen again. So here is the Skill Commons website. So if we go from statistic. So this is an OER from this OER repository. And here is the accessibility list of this OER. So so text access, structure markup, something like this.
Okay, thanks a lot. I would really like to have this slide. Thanks a lot.
Sure. Miroslav.
Hello. So I was just wondering whether you considered inputting any client assessments of the teaching content. I mean, in the working environment, you have this one bracket on assessment of the learner, but there, what I'm missing there is that if there would be some information about feedback collection, how the learner assesses the teaching content, that would actually gather you some additional information, which could be even combined with a very complicated predictive model on the metadata. So I was wondering whether you considered something in this.
So yes, you're right. Let me open the platform. So as Gabor showed you, for each of the recommended educational content, we receive the rate from the learners. So in the next few months, we will get more users and we will get more feedbacks regarding these educational content ratings. And based on them, yes, you are right. We can use these ratings in order to fine tune our models and validate our models. Yes, exactly.
Yeah, I think we're facing a bit of a cold start problem, but I think what's some interesting potential here is that even the assessments of individual learners can be used to score the content. Sorry, my phone is ringing. So even the assessments of learning can be used to score the content of or the quality of the educational content that the learner went through. In theory.
Yes, you mean we can use the grades in order to assess these past content?
Yeah, so if all learners coming out of a particular YouTube video don't demonstrate any increase in knowledge, then that says something about the YouTube video.
Yes. Yes, exactly. And one short comment here. I think Gabor didn't show this to you. So when I want to go to the next topic, here I need to answer a short question. So here for, can see this because of maybe, oh, this is not here. It's me. And with these questions, I think we can exactly do what Stefan mentioned. So I don't know why this question missing. So I need to pass a question in order to go to the next topic. And here we can exactly do what Stefan mentioned. Validate the quality of the past educational content.
Good. Yeah, thanks, Alan. Very quick.
Yeah, just feedback from a developer point of view. You can use tools to measure accessibility, so you can also triangulate against the quality. The tool, for example, inbuilt into Chrome has Lighthouse to generate some data as well.